Hi everyone, this is Kiranmai from H&S department. Today in this session, we are going to discuss about a photodetector, how it works, and one of a photodetector, that is a pin diode. So under this topic, we are going to discuss about the construction of a pin diode, working of a pin diode, characteristics, advantages, disadvantages, and applications of pin diode. With that, what is the basic principle that a photodetector follows? First of all, what is a photodetector? A photodetector is a device which absorbs light energy and converts this optical energy to measurable electrical signals. These photodetectors are mainly used for sensing purpose. The photodetectors are operated in photoconductive mode, where the semiconductor photodiodes are most commonly used detectors. Most of the photodetectors are made of silicon, germanium, gallium arsenide, indium gallium arsenide are used to fabricate photodiodes. Coming to the working of a photodiode works like when there is no light in the when there is no light illumination, the reverse bias draws a current through a current carrying electron and holes out of the p-n junction region and creating depletion region. Hence there is no current through the diode. This is the case when you take a p-n junction diode in reverse bias condition. What happens due to reverse biasing, that is p-type connected to negative terminal of the battery and n-type connected to positive terminal of the battery? Due to the attraction from the terminal ends, holes will move from P side towards the negative terminal, and electrons in the N side move towards the positive terminal of the battery, thereby increasing the depletion region between the P and N type materials. Hence, the width between the P-type to N-type materials get increased. Now, when light falls on the detector, what happens? Photons with proper energy, when it strikes this active region which is in between p-type to n-type material, what happens due to the light illumination, the ions in the region absorb that energy. If the sufficient energy is there, then electron hole pairs are created by raising electrons from valency band to conduction band, leaving hole behind. Thus, carriers drift quickly from junction, creating current which is proportional to intensity of incident light. So, whatever the light energy which is fallen on the active region, due to that, the electron hole pairs were created. That carrier concentration was completely dependent on the incident light energy, and the wavelength at which this detector responds to the light depends on the detector material composition. For suppose if the material which is used for the fabrication of p-type and type materials changes, then also the wavelength of the incident light depends upon those materials to excite the electrons from valency band to conduction band. We have to change the wavelength, incident wavelength, depending upon the detector material composition. If the composition changed, obviously the incident light intensity should be changed. Wavelength should be changed so that that sufficient wavelength will make those electrons to drift from valency band to conduction band. This is the basic principle what a photodetector follows, that it should be operated in reverse bias condition where they were illuminated with light energy. Now coming to the one of the photodetector, that is a pin diode, where in the name itself it is mentioning you are going to have three layers. One is p-type, second layer is intrinsic layer, third layer is n-type layer. So p-i-n, p-type, intrinsic and n-type layers. These three layers are developed on one another, so that an intrinsic layer is sandwiched between a p-type and n-type material, creating electric field between them. So the intrinsic layer is sandwiched between the p-type and n-type layer. This intrinsic region works like an active region where you are supposed to eliminate light energy. Coming to this P and N regions, these are there, and the region between them consists of intrinsic material, and the doping level is set to be very low in this region. For suppose whatever the material you are supposed to take for the P and N regions, they are lightly doped, and the thickness of the intrinsic layer should be very narrow, so that which is about 10 to 200 microns, and these P and N regions, which are on the both sides of the intrinsic level, they are heavily doped. The changes in the properties of the diode are known from the intrinsic material, and generally these diodes are made of silicon material. And this pin diode acts like an inferior rectifier, which is used in various devices such as attenuators, photodetectors, fast switches, high voltage power circuits, and so. So on the screen, you can observe the constructional figure for a pin diode where an N-type substrate and a P-type substrate is separated by an intrinsic region. And this intrinsic region is covered with a glass window which is illuminated with photons. And two electrodes are taken out of, one from the N substrate and the from the P substrate, which works like a cathode and anode. Coming to the working of a pin diode, this pin diode is mostly operated in photoconductive mode where a reverse bias is applied. When the light falls on the detector, when you give a photons of proper energy, those photons are absorbed by the electrons in the material and they will get excited from valency band to conduction band, leaving holes in the valency band. That means the proper energy photons creates electron hole pairs in this region by rising electrons. These carriers drift quickly from the junction, creating current which is proportional to intensity of light incident on the intrinsic region. So on the screen, you can observe that when the pin diode is connected in reverse biasing conditions and the radiations of certain energy being incident on the intrinsic region, so that creating electron hole pairs. This is reverse bias condition where negative terminal is connected to P type and positive terminal is connected to N type. And also P plus and N plus represents that this material is heavily doped. If you just see P and N, those are normally doped materials. If the type of material is indicated with a plus symbol, then it says that those materials are heavily doped materials. And intrinsic is lessly doped ones. So when you illuminate this region with light intensity of E and light of energy E, then electron hole pairs are created. Holes will move towards the P junction. Electrons will move towards the N junction, N type material. So by that, current will be produced in the circuit. Coming to the characteristics of a pin diode, the photocurrent generated is independent of the amount of incident optical power. As more photons incident on the active region, more charge carriers are created, hence more photocurrent. Okay. And the photocurrent can be given as a product of responsivity into optical power. At high light intensity, photodiode is saturated due to depletion of carriers, thus excess photons are not absorbed. So you can see the characteristics of a pin diode, which is drawn between power and photocurrent. So as the power output is increasing, photocurrent is also increasing. Coming to the advantages of a photodiode, this photodiode produces very low noise. Its dark current is very low. Biasing voltage is also very low, and higher reverse voltages to be tolerated. High speed response, low junction capacitance, and large depletion region due to reverse biasing conditions. Coming to the disadvantages, this is less sensitivity, no internal gain, small area, slow response time, and high reverse recovery time due to power loss are significant. Then coming to the applications, these diodes are used in the radio frequency and also for the microwave switches and microwave variable attenuators, since they are said to have low capacitance. And these are used in photodetectors and photovoltaic cells, and pin diodes are used for fiber optic network cards and also switches. These are certain applications. The other application is for radio frequency protection circuits and used as radio frequency switches also. And this is mainly used for the detection of X-ray and gamma rays. Most important application for the pin diode. Thank you.